To quickly familiarize yourself with equipment, conduct thorough equipment walkthroughs by physically inspecting each piece, paying attention to its components, functions, and any visible issues. Review technical manuals and drawings. Read and understand the equipment's operating instructions, maintenance schedules, and schematics to gain in-depth knowledge. Consult with experienced personnel by asking questions to senior maintenance technicians or plant engineers who are familiar with the equipment's history and characteristics. Utilize digital resources by exploring online databases, manufacturer websites, and video tutorials to supplement your understanding of the equipment. Attend training programs. Participate in company-organized or external training sessions specifically designed for the equipment being used. To apply preventive measures, establish a maintenance schedule. Create a plan that outlines regular inspections, cleaning, lubrication, and adjustments based on the equipment manufacturer's recommendations. Implement condition monitoring. Use sensors, gauges, and other monitoring devices to track equipment performance and identify potential issues before they become problems. Perform root cause analysis. Investigate any recurring equipment failures to determine their underlying causes and develop preventive actions. Improve maintenance processes. Regularly review and optimize maintenance procedures to ensure they are effective, efficient, and minimize downtime. Regarding corrective measures, provide rapid response. Respond promptly to any equipment malfunctions or failures to minimize production losses. Ensure accurate diagnosis. Identify the root cause of the problem through thorough troubleshooting and analysis. Enable effective repair. Utilize appropriate repair techniques, materials, and tools to restore equipment to its optimal functionality. Document maintenance history. Track all maintenance activities, repairs, and replacements to monitor equipment performance and identify trends. Allow for continuous improvement by regularly evaluate corrective measures and make adjustments to improve their effectiveness and prevent future failures. Elaborating further, a detailed equipment walkthrough involves systematically examining each piece of equipment in your facility. Begin by visually inspecting the exterior, noting its overall condition, any signs of wear or damage, and the presence of safety guards or mechanisms. Next, familiarize yourself with the equipment's major components such as motors, pumps, valves, control panels, and sensors. Understand the function of each component and how they interact with each other to achieve the equipment's primary purpose. While conducting the walkthrough, pay close attention to any visible issues such as leaks, unusual noises, vibrations, or overheating. Document these observations and report them to the appropriate personnel for further investigation. Thoroughly reviewing technical manuals and drawings is crucial for gaining an in-depth understanding of the equipment. These documents contain valuable information about the equipment's design, operation, maintenance, and troubleshooting procedures. Begin by reading the equipment's operating instructions, which provide step-by-step guidance on how to properly start, operate, and shut down the equipment. Next, study the maintenance schedules, which outline the recommended intervals for performing routine maintenance tasks such as lubrication, filter changes, and inspections. Schematics are essential for understanding the equipment's internal workings and how its components are connected. These diagrams illustrate the flow of electricity, fluids, or air through the equipment, allowing you to trace potential problems and identify their root causes. When reviewing technical manuals and drawings, take notes and highlight key information for future reference. Consulting with experienced personnel, such as senior maintenance technicians or plant engineers, is an invaluable way to gain practical knowledge and insights about the equipment. These individuals have likely worked with the equipment for many years and possess a deep understanding of its history, characteristics, and common issues. Prepare a list of questions to ask experienced personnel focusing on areas where you lack understanding or require clarification. Ask about the equipment's operating quirks, common failure modes, and any undocumented maintenance procedures. Experienced personnel can also provide valuable tips and tricks for troubleshooting and repairing the equipment based on their real-world experiences. When consulting with experienced personnel, be respectful of their time and expertise. Listen attentively to their responses and take detailed notes for future reference. Digital resources, such as online databases, manufacturer websites, and video tutorials, can supplement your understanding of the equipment and provide additional learning opportunities. Online databases, such as those maintained by industry associations or equipment manufacturers, contain a wealth of information about equipment specifications, maintenance procedures, and troubleshooting tips. Manufacturer websites often provide access to technical manuals, schematics, and other documentation for their equipment. Video tutorials can demonstrate how to perform specific maintenance tasks, such as replacing a filter, lubricating a bearing, or troubleshooting a control circuit. When utilizing digital resources, be sure to verify the accuracy and reliability of the information. Cross-reference information from multiple sources and consult with experienced personnel if you have any doubts. Attending training programs, whether company organized or external, can provide you with formal instruction on the equipment and its maintenance procedures. These programs are typically taught by experienced instructors who possess in-depth knowledge of the equipment. Training programs may cover a variety of topics, such as equipment operation, maintenance, troubleshooting, and safety. Some training programs may also provide hands-on experience, allowing you to practice performing maintenance tasks under the supervision of an instructor. When attending training programs, be an active participant. Ask questions, take notes, and engage in discussions with the instructor and other participants. Establishing a maintenance schedule is a fundamental aspect of preventive maintenance. A well-designed maintenance schedule outlines the regular inspections, cleaning, lubrication, and adjustments that are required to keep the equipment in optimal condition. Begin by reviewing the equipment manufacturer's recommendations for maintenance intervals and tasks. These recommendations are typically based on the equipment's design, operating conditions, and expected lifespan. Consider the equipment's specific operating environment and adjust the maintenance schedule accordingly. For example, equipment that operates in a dusty or humid environment may require more frequent cleaning and lubrication. The maintenance schedule should be clearly documented and communicated to all relevant personnel. Use a computerized maintenance management system or other tracking tool to ensure that maintenance tasks are performed on schedule. Condition monitoring involves using sensors, gauges, and other monitoring devices to track equipment performance and identify potential issues before they become problems. This approach allows you to detect early warning signs of equipment failure and take corrective action before a breakdown occurs. Common condition monitoring techniques include vibration analysis, oil analysis, infrared thermography, and ultrasonic testing. Vibration analysis measures the vibration levels of rotating equipment, such as motors and pumps, to detect imbalances, misalignments, and bearing wear. Oil analysis involves analyzing the lubricating oil of equipment to detect contaminants, wear particles, and changes in viscosity. Infrared thermography uses a thermal imaging camera to detect temperature anomalies in equipment, which can indicate overheating or insulation failures. Ultrasonic testing uses high-frequency sound waves to detect cracks, corrosion, and other defects in equipment. By implementing condition monitoring, you can proactively identify and address potential equipment problems, reducing the risk of breakdowns and extending the equipment's lifespan. Performing root cause analysis is essential for preventing recurring equipment failures. This process involves investigating the underlying causes of equipment failures and developing preventive actions to address them. When an equipment failure occurs, gather all relevant information, such as the equipment's maintenance history, operating conditions, and any witness statements. Use troubleshooting techniques to identify the specific component or system that failed. Once the root cause of the failure has been identified, develop preventive actions to address it. These actions may include modifying the equipment, changing operating procedures, or implementing additional maintenance tasks. Document the root cause analysis process and the preventive actions taken. Track the effectiveness of the preventive actions to ensure that they are preventing future failures. Improving maintenance processes is an ongoing effort that involves regularly reviewing and optimizing maintenance procedures to ensure they are effective, efficient, and minimize downtime. Begin by analyzing existing maintenance procedures to identify areas for improvement. Look for opportunities to streamline processes, reduce waste, and improve communication. Involve maintenance personnel in the process improvement effort. They are the ones who perform the maintenance tasks and can provide valuable insights into how to improve them. Consider using lean manufacturing principles to improve maintenance processes. Lean principles focus on eliminating waste, improving efficiency, and reducing cycle time. Regularly review and update maintenance procedures to reflect changes in equipment, technology, and best practices. By continuously improving maintenance processes, you can reduce downtime, improve equipment reliability, and lower maintenance costs. Providing rapid response to equipment malfunctions or failures is crucial for minimizing production losses. When an equipment failure occurs, it is important to respond quickly and efficiently to assess the situation, isolate the problem, and begin repairs. Establish a clear communication protocol for reporting equipment failures. This protocol should outline who to contact, how to report the failure, and what information to provide. Train maintenance personnel to respond quickly and effectively to equipment failures. This training should cover troubleshooting techniques, repair procedures, and safety precautions. Keep a stock of critical spare parts on hand to minimize downtime. This inventory should include parts that are prone to failure or have long lead times. By providing rapid response to equipment failures, you can minimize production losses and keep the equipment running smoothly. Ensuring accurate diagnosis is essential for effective repair. Before beginning any repairs, it is important to accurately diagnose the root cause of the problem. This involves gathering information, performing tests, and using troubleshooting techniques to identify the specific component or system that is failing. Begin by gathering information about the equipment failure. This includes the equipment's maintenance history, operating conditions, and any witness statements. Perform tests to isolate the problem. These tests may involve using diagnostic tools such as multimeters, oscilloscopes, and pressure gauges. Use troubleshooting techniques to identify the root cause of the failure. This may involve tracing circuits, checking fluid levels, and inspecting mechanical components. Once the root cause of the failure has been accurately diagnosed, you can proceed with the repair. Enabling effective repair involves utilizing appropriate repair techniques, materials, and tools to restore equipment to its optimal functionality. Before beginning any repairs, it is important to have a clear understanding of the equipment's design, operation, and maintenance procedures. Use appropriate repair techniques for the specific type of equipment and failure. These techniques may include welding, soldering, machining, and component replacement. Use high-quality materials and tools to ensure that the repairs are durable and reliable. Follow all safety precautions when performing repairs. This includes wearing appropriate personal protective equipment and following lockout-tagout procedures. After completing the repairs, test the equipment to ensure that it is functioning properly. By enabling effective repair, you can restore equipment to its optimal functionality and prevent future failures. Documenting maintenance history is important for tracking equipment performance and identifying trends. This information can be used to improve maintenance procedures, predict future failures, and make informed decisions about equipment replacement. Keep a record of all maintenance activities, repairs, and replacements. This record should include the date of the activity, the type of activity, the parts used, and the personnel who performed the activity. Track equipment performance data, such as operating hours, production output, and energy consumption. This data can be used to identify trends and predict future failures. Analyze maintenance history data to identify recurring problems and develop preventive actions. This analysis can help to improve maintenance procedures and reduce downtime. Use maintenance history data to make informed decisions about equipment replacement. This data can help to determine when it is more cost-effective to replace equipment than to continue repairing it. By documenting maintenance history, you can improve equipment reliability, reduce downtime, and lower maintenance costs. Allowing for continuous improvement involves regularly evaluating corrective measures and making adjustments to improve their effectiveness and prevent future failures. This process is essential for ensuring that maintenance procedures are up to date and effective in preventing equipment failures. Regularly evaluate the effectiveness of corrective measures. This evaluation should include analyzing maintenance history data, tracking equipment performance, and gathering feedback from maintenance personnel. Make adjustments to corrective measures based on the evaluation results. These adjustments may include modifying maintenance procedures, changing operating procedures, or implementing additional training. Implement a system for tracking changes to corrective measures. This system should include the date of the change, the reason for the change, and the personnel who authorized the change. Communicate changes to corrective measures to all relevant personnel. This communication should include training on the new procedures and a review of the reasons for the changes. By allowing for continuous improvement, you can ensure that corrective measures are effective in preventing future equipment failures and improving equipment reliability.